The AI ecosystem continues its rapid evolution. Today's users are quickly learning that the strategic integration of AI's various capabilities into holistic solutions is the key to unleashing the full power of the technology. But mapping this Venn diagram of a team's overall goals into an end-to-end AI strategy with components that work seamlessly together can be puzzling. Let's investigate how to make AI infrastructure transformation a little less mysterious. In this talk, I'll explore why AI agents are so powerful, what the main components of those solutions are, and then I'll delve into the role AI agents play in the virtual environment and how they actually enable these solutions. Then we'll put all the pieces together and go through an example. But first, what is it about these AI agents that are so powerful? So, unlike traditional AI models that are reactive and predictive, AI agents are initiative. They're goal-driven, context-aware. They actually maintain short and long-term memories, and they use that to learn, reflect, and adjust future behavior. They can plan things. They can plan things, and they can plan complicated things, multi-step workflows. And then secondly, they can interact within the metaverse to execute that work. So they can make a plan, and then they can get things done. This autonomous power is really helpful overcoming the huge hurdle that there is in incorporating AI into infrastructure. That complexity of combining use cases with the optimal combination of all of the different models available today, the software that connects these models, and the growing use of AI accelerator cards is a challenge that Agentic AI can help automate. Because what Agentic AI can do is autonomously assemble these puzzle pieces to form more useful solutions. And that can result in much, much higher inference and decision accuracy and much lower overhead and operational cost of finding these solutions because so much is not being done manually by the team. As a result, productivity of the team and of the AI solution itself goes up. How these agents do this has a lot to do with their ability to interact within the metaverse or the software ecosystem. So let's imagine we had an AI agent. That agent has ability to interact with many other things in the ecosystem, including APIs, so it can interact with customer applications, databases to get data and run models on, basically any resource that's available out in the cloud, as well as the software running on the box that the agent is actually running on, the actual computer that is running the program. In addition, in some cases, the firmware for some of these accelerator cards can also interact with the AI agent. My favorite piece of this is AI agents have the capability to interact with other AI agents. And those agents can then in turn take their task and communicate with the other pieces of the ecosystem in order to get their task done and then return control back to the AI agent. So to fully illustrate the power of what these agents can do, let's walk through a real-world example. Let's imagine we're a car insurance company modernizing our claim process. In this example, we would need an AI agent that is capable of doing claim processing. So we could create an AI claim agent. Now, this agent will need to get the claim data that came from the user. And because it's an agentic piece of AI, it can actually plan a workflow for what to do with that claim data. And then figure out how to execute it. So again, absolutely just a simplified example of all the different things that need to be done to process an insurance claim, but here's just a possibility of things that would need to be done that the claim agent could recognize and plan for. So a claim would probably need to be parsed. It would need to be matched with the policyholder's information, and make sure that this claim is allowed to be covered by this policy. There's likely going to be some image processing that needs to happen. There's likely going to be some fraud detect that needs to happen. As in almost any process these days, there's going to be some audit work that has to be done. And last but certainly not least, there is client interaction, because we might need more data from the client. And at the very least, we need to communicate the results of the claim back to the client. So there's many ways that this can be done, and that's going to vary a little bit based off of the ecosystem that the claim agent is running in. So depending on the resources that are available to it and what is in that ecosystem, it might make different choices for processing all the different steps of the claim. For example, to parse the claim, there could be available to this agent in the cloud a good NLP model that is effective at doing parsing. So it might outsource that parsing task out to the cloud. To do the policy match, an LLM is a pretty good choice. This claim agent could be working on an enterprise system with software that has capability to offload tasks to some, say, PCIe attached acceleration card that is really good at handling LLMs. So that interaction could be done to offload the policy matching work. The claim agent could then think, okay, I need to do some image processing. I need to look at these images and determine if they're fraudulent or not. What are these pictures of? Might have access to a bank of GPUs where it could send that work to and run the image processing model there. Fraud is a little bit interesting. There's many ways to maybe check for fraud, but it could so be that in this particular ecosystem, there is firmware that is controlling a card that is optimized for fraud detect models. And so the claim agent, if that is available, could send that over to the firmware, and that card could process and determine if there is fraud or if there is not fraud in the particular claim. If you haven't interacted with a database already in this process, the claim agent will certainly need to at least do that for the audit step. And then finally, at this point, most of the work is done, but the communication of the results and the output needs to go back to the client. I don't know about you, but I'm pretty sure the skills you need to process insurance claims are vastly different than the skills you need to interact with clients. Certainly that's true for a human, and I think that would map pretty well to AI agents as well. So this might be a really good use case to create a second AI agent. And this agent has a different specialty. This is a client interaction agent. So it has the tools and capabilities to interact with client applications. It might also need to reference databases, etc. And that is a more effective tool for getting the job done in terms of communicating the results back to the user. Just one very simplified example of how these different pieces can work together, but I hope I've given you at least a little hint of the possibility. So you see, like, while words like metaverse and agentic AI might seem mysterious on the surface, breaking the concept down into the different components and then thinking through how these components work together to form holistic solutions to real-world problems, very much like the AI agents do themselves. That's the key to understanding the real power of this technology and sparking inspiration for future possibility.